I think we have everyone. Because I thought someone is coming, but I think he's not coming. So, shall we start?
Sure.
Okay. So, okay, let me rearrange this to make it. Should be better now. Okay, so I received some feedback last time saying that the pandas might be a bit rushed the way I teach pandas. So I'm gonna review it today with everyone. So, okay, and after I review pandas, I'm gonna show a presentation about data visualization. And then I'll go over the code on how to create a graph. Okay? Okay, so okay, first of all, let's review the basic pandas function. I'll make it a little bit bigger. Okay, so first of all, first thing in pandas, how to create a data frame. Okay, just to review the way to create a data frame, it's make sure you put pd dot data frame. PD in here means pandas. Okay, and then dot data frame means that you are creating a data frame. So you can do it like this. If you create something like this, it will just simply give you a box, which means an empty data frame. Alternatively, it's actually quite flexible. The format I put here is actually a dictionary. Okay, so if you put this dictionary in here, it becomes a data frame. Okay, or you can do it this way. You put a list into a data frame, and it becomes a data frame. Okay, or if you put like a list of lists, okay, it becomes another data frame. Okay, I think the screen is clear. Okay, make sense? Okay, so just to make sure you understand, all you need is this thingy. This creates an empty data frame, and then it all depends on what you put in. Okay. Okay, so maybe I'll leave the example. So you can put 1, 2, 3, 1, 2, 3 in here, or you can put the one below, which is a dictionary. Okay. Or alternatively, you can read in. Oh, sorry.
But so the 1 to 3 and 4 to 3 is actually rows, 2 rows, right?
Yeah.
But in the next example becomes.
Oh yeah, that's true. So you need to put like something called transpose, and it becomes the format you like. But this way is a bit tricky, because the column names, sorry, the column names become 0 and 1. So you have to redefine the column names, and the way to redefine the column names is like this. Okay, if you redefine it, then it shows us A and B. Okay, so the first way is less popular. The more conventional way is to use a library, is to use a dictionary, because you can specify the column names.
And it becomes the row.
The column names. Okay, and okay, the second way to create a data frame is to put it from external source. Okay, so it can be a URL, or it can be a file that is located in your directory. Okay, maybe you're not aware, but every Jupyter notebook is located inside directory. Okay, so if you click header, click on Jupyter. It brings you back to the file system, and my notebook is located inside folder downloads. Okay, so that's my folder, that's my file. But if you want to read in something from your own computer, it has to be in the same directory, or you specify the path which links to that directory. Okay, and if you don't, you're not sure where is your directory, you can put import OS, which stands for operating system, and OS get current working directory, CWD, and then it shows your current path. And then if you do os.list directory, it lists out every single file in your directory. Okay, so let's say if I got this CSV which is in the same directory, I can simply put pd.read CSV and then put the file name. Okay, this file is not in your computer, so it won't work. But let's say if I run it, it just show me what's inside this CSV. Okay, so when you do your project, I'm sure you will have your CSV in your operating system. So that's the way to extract it or put it into your Jupyter notebook. Okay. Any questions on here? Okay. So, okay, the next thing for a data frame is after we created the data frame or we read in from external source. Okay, we want to play around and select the subset of a data frame. And the most common thing is to select a column. Okay, so how do we select a column? I'm sure you guys know about it. It's either df.a or you can do df square bracket a. Okay, just to remind you, the .a is just a way to make it convenient for you. But this is not very conventional, and sometimes it will make an error if you do this. So for a beginner, I suggest you to always stick with the bracket. Okay. And let's say you have a random data frame. Okay, we have this data frame AB. And let's say now you read it from like external data, and you want to list out all the columns at once. You can put df.columns. Okay. Or if you want to put it into a list, just put list df.columns. Okay. And of course, remember the characteristics where if we want to select 2 columns, you put it back and it selects the column for you. Okay, because this is a list. Okay. Okay. If you put a list inside the square bracket, it allows you to select more than 1 column. Okay, and there are alternative ways to select a subset from a table. So if you think about it, every table consists of 2 dimensions. One is the index, the other one is the columns. Okay, so if you specify the index and you specify the columns, then you can select anything, like any square or rectangle on your table. Okay, so the other thing is called lock. If you put df.lock, it allows you to select it by columns, row and columns. The first item is the index for your row, and the second item is the index for, not index, but for the character for the column. So if you put 1 and A, it means select the first index equals 1 and column equals A. Or if you put 0 to 2, okay, it selects index 0 to 2 for you. Okay. Very similar, but most of the time people get confused. It's between the other function called ilog. Okay, and the two performs very similarly. Let me make this smaller. Okay, the two perform similarly. Both consist of two parts. First part is the row. Second part is the column. But for ilog, the I stands for index. Okay, so all you need to key in is the number in the ilog. So if you put in A in here, it shouldn't work because A is not a number. So if you want to visualize it, ilog just use 0 to represent column A and 1 to represent column B. Okay, while in log it uses the column name directly. Okay. Any questions in this part? And please let me know if I'm going too fast. Okay. Okay, so we learned how to select a subset from a table. And the next thing we need to do is something more complicated, which is how to manipulate the dataset. Okay, let's say we want to add the new columns. Okay, we want to add a new columns called C. For now, the data frame is just A and B. And if we want to add a new column C, we simply make a list with the same length and just call it df square bracket C. And after you run it, it adds new columns called C.
So how is that like? So can I add like?
Yeah, you can't.
Before A.
Yeah, it won't. Like if you add something called Patrick. Okay. Sorry. Patrick. It's always gonna add on the right on it, but you can rearrange the order. I forgot to mention in here. If you want to rearrange, you can do Patrick C A B. Okay, you can rearrange it like this. But always have this in mind. If there's no equal sign, most of the time it won't change your original data. Okay, because in here I didn't put an equal sign, so my original data will still stay the same. Okay. Unless I put an equal sign onto my original data, then it will permanently change the value. Okay. Okay, what if after I create a column, I want to start to manipulate the column? Let's say I want to add functions that times 2 for every item in the column C. Okay, we have a function called lambda and a function called apply. Okay, so apply function I think it only works on columns. So we can do first select a column. Let's say I select column C. And now I want to apply functions on every single item on column C. The way to do it is to put apply. Okay, before I go to apply, we can always do it in a for loop, right? It says for I in dfc, and then you can do like I times 2. Okay, it works the same way, but for apply, you do it slightly differently. You code something called lambda. And what means by lambda is you create a variable that you throw away right after, which is equivalent to this I. Okay, if you think about it, this I, whenever we created it, we throw it away afterwards. So this I is constantly changing. And in this case, the x is your variable. And you are constantly changing the value of x based on what's on column C. And if you do x times 2, times 2, then you manipulate the value of DFC. But bear in mind again, because there's no equal sign, so you're not changing anything. You're just printing it on the screen. Okay, so if you want to change it, you have to put an equal sign and applying it back to your original data frame. Yep.
What if you want to change on the row 0 and 1?
Row 0 and 1. Okay, then you have pandas is not very friendly in doing so, but I think you can do .iloc. Okay, row 0 and 1. Okay, row 0. I think you can do this. Okay. Okay, this is row 0 and column C. Okay, and I think if you have to change a subset of it, you have to do it this way. Because pandas makes it easy for you to change the entire block of data, but it is way more convenient to change it on Excel if you want to do it cell by cell. Okay. Or alternatively, you can write an apply function, which is very complicated and it only applies on certain cell. You can write it like twist the logic and to make that happen. Okay. And yeah, if you apply it to column C, then it becomes like this. Okay. Any question for now? Okay. Which part? This part is to rearrange the column. Okay. Any other questions? Okay. All right. So okay, last time someone asked how to drop a column. Okay, I sort of Stack Overflow it and figure it out. So to drop a column, you just do df.drop and you specify the column. But in here, you have to specify which axis. Okay, so in Python, axis 1 means column, and axis 0 means index, which means the row. Okay, if you want to drop it by column, do 1, and then specify which column, the name of the column that you want to drop. Okay. Okay, so after I run it, I drop B and C. Or if you want to drop a specific row, you just put drop, specify which row, and then specify the axis. Okay. And in this case, because I drop row 1 and 2, and specify the axis is 0, so I drop row 1 and 2. Okay.
So the one showing is what you drop.
The one showing is what's remaining. Okay. Yes.
Say you create a new column for some temporary values and want to calculate.
Yes. Yes.
After the calculation, do you drop it or just leave that?
Okay. It really depends on the case. So let's say if I extract the entire, I don't know, like Amazon data in my data frame, I create one new column for every item on that list. But I'm actually creating a lot of data. If that slows down my computer, then I'll drop it. But if that doesn't affect my performance, usually I'll just leave it. Okay, because creating data is harder than destroying the data. That's what I believe. So I don't like to delete stuff. Okay.
It's also a way to track back what you did.
Yeah. Track back. Well, usually if you rerun your entire code, you can stop in the point that you want to stop. Okay, any question with the drop? Do you understand what's showing is what remaining? So the original data looks like this. Sorry. Okay, the original one looks like this, and I'm dropping this to row. Okay, so I specify 1 and 2, and access equals 0 means I'm dropping the row. So if I run it, the highlighted one are being dropped, so what's remaining is the one that is not dropped.
Then access 0 just
Okay. If access equals 1, that's mean column. If access equals 0, it means 0. Okay. So if I specify access equals 1, that's mean I'm dropping the column. If I change it to row here, it will give me a error because there's no row that's called B and C. Okay. Any questions? Yeah. Okay, so the fourth thing we usually do is, okay, we got our data set and we want to explore around it. Okay, usually the first thing you do is df.head. Okay, because usually when you load the data, you don't know how many rows it got. And if you want to have a peek at the structure, you can do df.head, and that only shows you the top 2 rows, and you sort of understand, okay, what's in this data. Okay, if you don't specify a number of rows, it will just give you the first few lines. The other way is to show the last 2 rows, which is the tail. So like df.tail. Okay, I'll show you some example on how to use this later on. Okay, once you have a peek on the structure, and then you will be interested in how big the data and what kind of data type is in the data. So okay, we have something called df.shape, which literally means the shape of it. So this is again, see the first item is row and the second item is column. And I think it applies to everything in Python. The first one has to be a row, second one has to be a column. Okay. df.info. Oops, it has to have a bracket. And then, okay, if you read the information in here, what's the most important is the data type. Okay, so object means there's a string in it. Integer means number. Float means number. Second most important thing is to check if there's any null value. So I remember Ting, you asked if the list is not at the same length.
Mm-hmm.
If you put it into their frame, what's going to happen? It's going to create a null value. So to check if there's any null value, just put df.info, and it will show you the null value in here.
but it does not tell you where exactly the node is.
For now, it does not. Okay, and don't underestimate the the annoy like how bad is a null value can be in the data, because if you run an analysis, there's no value, it's gonna crash your whole thing. So we have to figure out a way to remove them. Okay. And lastly is this describe function, which just simply tell you the simple statistics, like count, mean, standard deviation, blah blah. Okay. Any questions for now?
So why shape isn't that?
Okay, I think this is something quite annoying in Python. So, do you remember last time I said everything with a round bracket is a function? Okay. So, sorry.
Sorry to interrupt.
Yeah, it's okay.
But does anyone have a surface charge that we can borrow?
You mean Windows Surface?
Windows Surface, yeah.
There's a blockchain for that.
I don't know if anyone's using Surface Computer.
Alright, no worries.
Okay, alright. Okay, never mind. So, okay, this is a, okay, every time it has a round bracket, it's a function. Okay, but why this df.shape is not a function? Because when it write, so-called when they write the package, they probably have created an object called shape. Okay, so they are not calling it in a form of function, but they created that object and call it out from the package. So in this case, shape is actually an object. Okay. It's just how they write the code. Okay, if there's no question, let's go to the Harry Potter homework. Anyone have tried? How do you find it? Is it complicated or?
I'm not sure what I have done.
Okay.
That's a thing.
Okay.
I tried to do it,
yeah.
but
Yeah, I think trying is a learning process. I didn't expect you to do every single part, but like the reason why I asked you to do that is because what Panda does is give the data a structure. Okay, it gives it a very simple structure with row and columns. Okay, but if you looked at the Harry Potter text, okay, let's go to the Harry Potter text. Okay, this is a text, right? This is a human readable text, but it's not readable by computer. So if you put it into pandas, it gives it the structure, the boundary on. You slice it into different units, and it makes it way easier for data analytics. Okay, and it's way easier to plot any kind of graph if you put it into pandas. And okay, let's say now I read it into a data frame.
So when you read the whole text into a data frame,
Yes.
is that all text contained in one column?
Okay, you can have a look now. So, oh, sorry. Okay, let it load for a while, because it has to download the text. Okay, usually it's quicker than that, but
actually FW will take me.
okay. Alright, so okay, I think we're quite lucky that it's reading it in this format, because if you go back to text, every line should be bricked by something like this /n. if you looked into the source of it, or maybe ops. Inspect. Okay, because in its HTML, it sort of breaks it into a lot of TR. Okay, so if you read this kind of format into pandas, it will break it into every TR. It's a unit. Okay. Hello. And so if you read it into pandas, it becomes a format like this. So every so-called TR, which is a table, becomes a cell. Okay, and we have like 10,000, 10,000 sentences. But these sentences is not like human sentence, but it's a sentence perceived by the computer. Okay. So I'm sorry. Yes.
So when you set WF, you get 10,000.
Yeah.
But if you table, you get 9,000.
Oh really? Okay, I didn't notice that, but let's have a look.
It gets 9,781.
Then probably the way they split the table is different.
Okay.
So for
So
read,
that means those two reads will be different from each other.
let me try. It looks very similar to me, but let's say raw.shape. Yeah. So I think the way they split the sentence is a bit different. So they have different logic in splitting.
So what's the difference between read table and read
Yeah, what's the difference?
Well, have to go back to the pandas official documentation. Okay, so this is like for every popular package, they has official document. So whenever you have any questions, just go back to here. Read the table with fixed width format lines in here. So I think FWF kind of figure out the fixed width format. So I guess it automatically detect the right logic to split it.
Try something with the FWF.
Yeah.
Couldn't read the slash
/n. Okay.
But with the read the CSV,
It detects it.
yeah.
Okay. So I think normally when I deal with data, I just try read CSV first for everything. And then if it doesn't work, I try read table. If it doesn't work again, I try read FWF. Or I just go to Stack Overflow and see if there's any other options. Or there's another way in Python called IO. I think it's Python read text IO. Okay, so they have some very old school stuff that basically reads every single kind of file in Python. So it just breaks all kind of file line by line and read it. So if you do it this way, using this format, you basically can open anything, any single file that you can find on the computer. Like if you put like with open and then the file name, and then in here say for every line in F do something. This way for sure it works, but this way is very problematic, and it's not reading it into a pandas. So yeah, this is the last resort if you want to read in something. Okay.
So recommend.
table version followed by FWF.
I guess for if you know it's a CSV, just read CSV. If you think it's a text or any weird format, just do like read table. Or if it's a JSON format, just do read JSON. Okay.
So if you use read FWF, then the shape will be different.
Yeah, it will be slightly different. But because we're gonna reshape the data later on, so it doesn't matter.
Do they separate the lines or the rows?
Yeah, I think they separate the line differently. Okay, let's go deep into it. Say raw 2. Okay, it's gonna take some time. Okay, raw 2 is different, and raw 2, if you put it out, it looks quite similar but actually different. So if you specify the row in here, like select everything, and then what I would do is I would concatenate every single row. So if you do oops, sorry. Yep. Okay, if you do this, you basically paste everything into one long string. Okay. Probably I should put like a space in here. It's loading. Okay, then I read everything in here like a text file. Okay, everything is now in a long text. Okay, for the second choice, like the FWF, I guess it reads in using the slash or something similar. Okay, but let's say string 2, and then we have string 1, then row. Okay. Okay, string 1 and 2 should be quite similar. Okay, this is string 1, and then we have string 2. Okay, I think they are the same thing. Let's say if I count the length. Okay, 607443. Let's count the length of the first one. Okay, they're slightly different. Okay, I will have to do some research on why are they different. But I guess it's the comma or it's the slash. The comma and the space. The space. Yeah, probably. Okay, let me go through the entire thing using the second method, and we'll try it on the first one to see if they are very different. Okay. Okay, so the first task is to count the number of paragraphs. Best practice with data science is have a look at the data first. If you can open it in an easy format. Okay, so let's have a look how to deal with this problem. If you want to split by chapter, okay, you see every chapter begins with the word chapter. Okay, so maybe that's a good way to split it. Okay, so how do we split it? Okay, the first task is just to count how many chapters are there. So let's select first column, do the apply, lambda, and if the word chapter is in X, then it becomes true. If not, it becomes false. Okay, then you have one true in here. And because true means 1, so do the sum of the entire thing. Okay, it becomes 22. Okay, that's something we went over, like the apply function. So I hope you understand what's going on here. Okay.
So the second is I told you this apply function
Yes.
is when you want to search for a word and to see it appears in each line,
Yes.
and then just use lambda x and then your word index.
Yes. So what apply actually means is it go through every single member. Okay, if I do an apply function on a class, it will just ask you, okay, are you chapter, are you chapter, are you chapter, are you chapter, are you chapter? Okay, go through everything, and then you give me a response, say yes or no. And yeah, basically that's the logic of it. Okay, or you can use a list comprehension. Now it looks a bit messy, but let's say if you pick this out, let's say X, that might be more readable. Okay, I put X, I put the first column into variable, and then I just put the variable to a list comprehension, and check whether or not chapter is in I. Okay, and this is like another way to do it. Or you can do contains. You can put everything to a string and then check if they contains the word chapter. Or you can run, I think you should read this at home because I don't want to go through line by line in here. But this is how you put it into like a structured format. Okay, you have text in the first column and a chapter in the second column. So you specify which sentence belongs to which chapter in here. So you start to give it a little bit of structure. Okay, and then the second thing is how to split by sentence. Again, I think we don't have time to go through it line by line. So basically, I just use a join function to join every single text. And then here you have something called RE. RE is when you do something called regular expression. Regular expression is a very complicated way of splitting string in computer science. So if you do regular expression, and then there should be some tools that if you want to extract certain text, okay, just follow the format, and then this means select everything from A to Z in the paragraph, and if you change some characters, and then it will just select different stuff from the text. So this is very advanced, but if you go to Stack Overflow, and then many of the combinations has been done for you. So how I do it is I just copy the regular expression, and in here it means I'm splitting it every time I see a full stop, question mark, and an exclamation mark. Okay. And if you ignore the length, oops, sorry, I think I have to import. Okay, if you ignore the length, it shows you this way. So now every line, let's say if you specify the first one is the first sentence, sorry, and then the second sentence. Okay, so it's just some tricky way to give some structure to the data. And again, I won't go through all of them, but the way to count the number of sentences per chapter is basically sorry. Okay, now you have a data called df, and remember, how do I select a specific chapter? Let's say if I want to select only chapter 1. How do I do it? Chapter 1. Okay. df square bracket chapter, and then chapter equals 1. It gives you some boolean. It only says shows true on those satisfy the condition, and you put it by a square bracket, and basically it gives you the data that only belongs to chapter 1. And if you count the length of it, it's 353. And if you loop through these numbers, it gives you the count of sentence for every chapter. And eventually, it shows you this graph. Okay. Okay. So now that we created a data frame called sentence_df, and if you want to plot it out, you use a library. Okay, the library is called matplotlib, and then okay, I'll show you how to plot it. Okay, I have this. Sorry. Okay, now I have this data frame, and I want to plot something. So if I want to plot something out of a data frame, I put dot plot, and then okay, you specify the x and y axis. So y equals number of sentences, and x equals chapter. Okay, if I run it now, it doesn't show me anything because I didn't specify plt.show. Okay, then if I run it now, I can now start to have an overview of how's the Harry Potter novel distributed. Okay, so now you know it's not even. So some chapters have more words or more sentence, while the last two or fourth chapter has way less sentence, and the last one is a lot longer. Okay, and I think that kind of summarize how the chapter goes, because I think this is a chapter where Harry Potter fights Voldemort, the bad guy, and the last chapter is how Harry Potter went home and united with his friends and family. So it's a very long chapter.
Like how do PLT interpret like those axes? Like whether it is a date or string or integer.
Okay. In this case, it's all integer. Okay.
So it's automatic.
Because if you looked into the data, hold on. .info. Okay, you can tell these two are integer. Okay, but if let's say if I put this chapter into a string, then it will show it in the order of the data. It will just treat it instead of a continuous value. It shows it as like a string. Okay. Okay. Any question for now?
Why the index of the rows are also
Index of the row. Okay, good question. It depends on how I formatted the data. Hold on. Okay, when originally it has an index of 1 to like 10,000, and then okay, in this line I do pd.concat. Okay, what it means is in here I'm putting every slice of the airframe into a list. So this empty string is actually a list of the airframe. If I put like this, it's the first airframe. If I change it to another one, it's the second airframe. And if I select the 1 and 2, and I do pd.concat, sorry, 1 and 3. Okay, let's start to combine the data frame from the bottom. So if I keep on adding it, okay, it adds up. But the reason why that is 0 is because when I create this data frame, this is supposed to be the first item in that subset of the newly created data frame. So if I combine many data frames with just one row, then that index will be 0. Okay. It's not very important, but let's say, okay, let's say I create a data frame like this. Okay, if I create an empty data frame with just one row, the index will always be 0. Okay, if I put such thing into a list, okay, it will become something like this, which doesn't make sense because this is a list of 2 data frames. And if I want to combine them, I do pd.concat, and it becomes like this. Okay, and you can see the index becomes 0. And it really doesn't matter in this case. You can rearrange the index later on. Okay. Okay, so split by word is very similar. Instead of split by like comma, I just split by space. Okay, because between every word it has to be a space. Okay, and I replace all the I don't know how to say this, like full stop, comma, question mark, etc. And then I count all the number of words. And this piece of code is very similar to the one above. So it's basically the same piece of logic. And then if you plot it out, it's the same. Like the graph looks very similar. Okay. And then okay, maybe this exercise is a bit too complicated. Hold on. Okay, if you want to count the character, basically if you want to count the number of character that appears, you have to first have a list of characters. Okay, this is my list of characters. And then what I do is basically look through every single one of them, like search for the word Harry in every single sentence and count them. And that's how I count the number of Harry appears in the novel. And okay, if you run this, the first 2 lines should be quite self-explanatory. Okay, so I'm just creating a data frame called Harry Potter with all the chapter. And then the second piece of logic is I loop through every single character and I put it into this function. And then basically this function helps me to count how many times the word Harry appeared on every single chapter. And then I'm just shaping them to a final data frame like this. Okay. So if I want to visualize something using pandas, I have to put them into a table like this. Okay, and if I want to plot out the times Harry appear in chapter 1, blah blah blah, I just put it like this. Harry Potter.plot y equals all the columns I want to plot, and x is the x-axis. Okay, and it shows you some amazing visualizations. Like this way you can just visualize which are the important characters. Like Harry appear very often. Voldemort is like non-existing and appear slightly more often towards the end. And let's say if you want to hold on. Okay, like in this field, usually we normalize stuff. Anyone know what's normalization? Okay, normalize means you put everything into the same unit, or you put a percentage out of it. So in here, the counts is like 150 for Harry and I don't know, like close to 0 for the less important characters. And if you put it into percentage, then it sort of gives you a better idea on like the ratio between the frequency. Okay. And just one more thing is the character interaction. So I'm simply counting whether or not the same 2 character appears on the same sentence. Okay, so again it's the same logic, but I just count it 2 times. Okay, then I have some interaction terms, which is how many times Harry and Hermione happens at the same time, or Harry and Ron appears in the sentence at the same time. And then you can see the pattern is quite consistent. So it means that they are always together. Okay. Okay, let's stop here for now, the Harry Potter, and then I'm gonna show you a presentation on data visualization. Do you guys need a break? Because today is quite packed. Are you okay? Or do you need it? Is it okay? Okay. Okay. Right. Okay, let's have a 10 minutes break then. 係
想問下咧，let's say 如果你有呢個 graph 啦，即係有嗰個呢一個啦，即係 number of Harry 同 Ron 咁樣。
係。
咁其實嗰個即係如果我哋想之後教嗰啲 prediction 啊，我即係 let's say 我可唔可以 predict 佢之後嗰5個 chapter 嗰個 interaction 嗰個或者個 correlation，可唔可以即係當我有呢個 graph 之後，可唔可以 plot 到出嚟？即係 predict
喺呢個 case 未必咯，因為呢個 case 係，因為呢個 case 咧，你小説嘅頭一半同尾一半嘅 pattern 未必係有個延續性喺度。反而咧，如果你用頭3本書嘅 pattern 嚟 predict 第4本書嘅 pattern，
OK，
就可能
唔好用每個 chapter 用嗰本書。
係啊。
即係
即係書與書之間嘅可比性高啲。如果你係 chapter 嘅前一半同後一半嚟比，就冇乜關係。
即係 let's say 譬如我有即係3本書，咁我有晒3個依嘅 graph，咁我就可以利用呢3本書嗰啲 correlation 嚟比第4本，
會 make sense 啲咯。
OK。咁但係之後我哋都會教點樣去利用，即係點樣即係 linear regression 或者好多唔同嘅 modeling 咧，即係都會教，跟住再點樣
會教 prediction。
OK。
跟住就開始啦。不過我見你係中意睇佢做好多，可唔可以 run through 即係
其實我錄低咗。